Hello, welcome back to our magic tutorials for chemistry. We will discuss today about coordination compounds. So, before we move into the chapter, let us take an example of a coordination compound. I will take the example of K4 FeCN6. Okay. This is an example of a coordination compound. So, what are the terms related to coordination compound, right? Before going into the chapter, before learning the nomenclature, we need to know what are the terms related to coordination compound. So, coordination compound, it is also called as a complex. Coordination compounds, they are also called as a complex. They are also called as a complex, correct. Why they are called as a complex? Because they have charge, they are negatively charged or positively charged. For example, another example, correct, PtNH3 whole 4 2 plus, and one more example, FeCN6 4 minus. So, 3 examples I have written. So, we will discuss what are the terms related to coordination compounds. So, coordination compounds, they are also called as complexes because they are positively charged or negative charged. That means they are electrically charged species, right. Now, if it is having a positive charge, like in example number 2, if it is having a positive charge like in example number 2, then it is called as cationic complex entity. It is called as cationic complex entity. Cationic complex entity. If it is having a negative charge, it is called as anionic complex entity. Anionic complex entity. Okay. The next term, that is central atom or central metal atom. Central atom, also called as central ion, also called as a central metal atom, CMA, central metal atom, correct. So, what is a central metal atom? The atom, this is the central metal atom, the atom to which a fixed number of groups are bound. Okay. So, this is the atom, the central metal, you can see they are the metals, and mostly these metals will be belonging to D block, right. So, this is the central metal atom. So, it is an atom or an ion to which a fixed number of groups are attached. You can see here 4 groups of NH3, 6 CN, correct, 4 NH3, they are attached. So, that is a central metal atom. The next term, that is ligands. So, in coordination chemistry, negative species are called as the ligands. So, what are ligands? Electron donating species, correct. Ligands, they are negatively charged, that means they will have electrons, so they can donate electrons. So, they are electron donating species or electron donating groups. So, ligands are electron donating groups attached to the central metal atom. So, what we have written in the small bracket, they are the ligands, negative species. They are attached to the central metal atom. They are ligands. Next, what is a coordination number? What is a coordination number? Coordination number. So, how many bonds? The number of bonds made by the metal and the ligand, correct. The number of coordinate bonds formed by the metal and the ligands, metal with the ligands, right, how many bonds they are making with each other. So, that is called as the coordination number. The next is the coordination sphere. The central metal atom and the ligands, they are enclosed in a square bracket. The central metal atom and the ligands, they are enclosed in a square bracket which is called as a coordination sphere. The next one, that is counter ions. Counter ions. So, the ions which are present outside the bracket are called as counter ions, right. The ions which are present outside the square bracket. So, you can see this is the square bracket here. Which ion is present here? Sulphate ion is present outside. Over here the square bracket, which ion is present? K4 outside, correct. So, the ions which are present outside the square bracket is called as the counter ions, correct. If it is on the left hand side, it will be positive. If it is on the right hand side, it will be negative, correct. So, these are the terms related to coordination compounds. Hope it is clear to you. So, in coordination compounds, in the square bracket we have a metal, I just write as capital M, and we have the ligands, right. We have the metal and the ligands inside the square bracket. So, ligands, they are negative species, they are electron donors, correct. They donate electrons to the central metal atom. So, they are called as Lewis base, and the metal, it accepts the electron from the ligands. So, it is called as the Lewis acid, correct. And between the metal and the ligand, a coordinate bond is formed, and as the coordinate bond is formed, these compounds are called as coordination compounds. They can also be called as complexes. So, we will move to the next topic, naming of a coordination compound, how to name the nomenclature. So, for that I have given here two examples. So, just we will identify first which is the central metal atom. Fe is the central metal atom in this compound, Cu is the central metal atom. Okay. Now, in small brackets it is written, they are called as the ligands, right, they are the ligands, and outside the square bracket you can see the ions, they are called as the counter ions, correct. So, Fe and Cu, they are called as the central metal atom, right. NH3 and Cn over here small brackets, they are called as the ligands, negative species, and outside the square bracket it is called as the counter ions, they are the counter ions. So, let us check what is the first rule here. So, the first rule is always name the cation first, name the cation first, that means name the cation, that is a counter ion first, if it is on the left hand side. I told you outside the square bracket the ions what is present is called as a counter ions. The positive ion will be present on the left hand side, the negative ion will be present on the right hand side, correct. In the previous example I have given you as K4, that means it is a cation because it is present to the left of the square bracket. So, it is a cation. So, first you will name this, what is K? It is potassium. Okay. Suppose in some compounds the cation or the counter ion it is not present. So, we can directly move into the square bracket. So, how you will name there? You have to name the ligands. If suppose the cation counter ion is not present, that means you will name the ligands. You will name the ligands. Now, how to name the ligands? So, the ligands should be named in alphabetical order. Maybe sometimes more than one ligand is present in a compound, right. So, you check the name of the ligands and arrange them in alphabetical order. And if there are more number of ligands, then use the word di, tri, tetra. If there are 2 ligands, you can use the word di. If more ligands, tri. 4 ligands, tetra, right. Now, if the ligand name already contains a number, for example, I write as En, that is ethylene diamine compound, correct, ethylene diamine compound. Okay, one more I will write, that is EDTA, that is also a ligand, it is ethylene diamine tetraacetate, right. So, you can name see here that the name of the ligand itself, it contains the word like di, tetra, correct. So, what to do in this case? So, at that time if the ligand name has a number, you will name the ligand as, suppose if it is bi or di, you will name the ligand as bis. If it is tri, you will name the ligand as tris. If it is tetra, you will name the ligand as tetrakis. If it is penta, you will name the ligand as pentakis, correct. So, you have to name the ligands in the alphabetical order. You can use the numbers, if the number of ligands are 2, 3, 4, then please use the words like di, tri, tetra. If the ligand name already it has the word di, tri, tetra, then you have to use these words for naming the ligands, correct. Now, suppose the ligand, it is ambidentate ligand. Now, what do you mean by ambidentate ligand is, the ligand has 2 donor sites, but it will donate from one donor site. It will donate from one donor site, that is called as ambidentate ligand. So, you have to name the donor site also. Ambidentate ligand, for example, if it is CO, NH3, 5, NO2, Cl, correct. Suppose if it is CO, NH3, 5, ONO, Cl, correct. So, here it is called as ambidentate. You can see here NO2 I have written as this ONO, that is also same ligand, but here N is donating, this is a ligand. So, N is donating the electrons to the central metal atom, but in the second case oxygen is donating the electrons to the central metal atom, correct, but the ligand is same, but the donating site is different. So, in such cases where ambidentate ligands are present, you need to mention the donor site also. So, while writing the name of the ligands, if it is a ambidentate ligand, if ambidentate ligand is present, the next rule, ambidentate ligand is present, then mention its donor site, mention its donor site, correct. Now, the next rule, if an element is present at the first, that means if the cation is present, if the cation is present like K4, correct, before the square bracket on the left hand side, then the name of the metal, the central metal, name of the metal, it will ends with ATE, remember this. If there is a cation, counter ion, the counter ion, it is a cation present on the left hand side, then the name of the metal will end with ate. Now, if the counter ion is present at the last, negative, that means on to the right hand side counter ion is present, then it is written as it is, then the name of the metal will be as it is. Okay. and the counter ion name will be written at the last. And the counter ion name will be written at the last. So, hope these rules are clear to you. So, before we move on to the naming of the coordination compounds, you need to find the oxidation state of the central metal atom, right. To find the oxidation state of the central metal atom, we need to know the charge on the ligand. So, here is an image for you, just make a note of that image and also the names of the ligands. We will take a simple one first, right. So, first, is there any cation present as the counter ion? Yes. So, the cation is present. What is the name of the cation? K stands for potassium. So, I will write the name as potassium. Potassium. Now, come to the ligands, right. So, which is the ligand here? Ag is the central metal atom, Cl is the ligand here. So, Cl is the ligand. How many Cl are there? 2, right. So, the name will be dichloro. Now, if the central metal atom, that is the cation, is present in the left hand side of the bracket, then the name of the central metal atom will end with ate, correct. So, what it is? Ag stands for what in silver? Argentate. So, the name will be argentate. Now, you need to write the oxidation state of the central metal atom in square bracket in Roman letters, correct. So, let us calculate that. So, we know for potassium it is +1, check for here, potassium it is +1 plus Ag we have to calculate. So, let us put it as x value plus Cl, how many Cl are there? 2 Cl, and each Cl the valency is charge is -1 equal to 0, right. If you calculate, find the value of x here, the value is 1. So, I will write it as Roman 1. So, charge on the central metal atom, oxidation state of the central metal atom is 1, right. Let us take the next example, K3 Fe Cn6. Okay. How to name it now? Again we can see that the cation is present here. So, the name will start with the cation, potassium, K stands for potassium. Come to the ligands now, which is the ligand which is written in the square bracket. How many are there? Hexa, 6 are there. So, hexa. What is for the ligand name? It is cyanide group, but in the name we write it as cyano, hexa, cyano, right. Now, again the cation is present, so the name of the central metal atom will end in ate. So, this is ferrate. Now, calculate the oxidation state here for the central metal atom. Potassium, it is 3 into 1, right, plus Fe we have to calculate, that is x value, cyanide 6 into -1. So, for Fe if you calculate this, x value will be 3. So, Roman 3, correct. So, this is the way we calculate. Yes. So, the third example, it is FeCO5. So, here no cation is present. So, directly we will name the ligands here. So, what is the ligand here? CO, that is carbonyl, right, it is carbonyl. How many carbonyls are there? 5. So, it is pentacarbonyl, it is pentacarbonyl. Now, the name of the central metal atom will be as it is, name of the central metal atom as it is. So, I will write it as ion, carbonyl ion. Now, find the valency, the oxidation state for the central metal atom, right. So, how much it is, how to calculate. So, carbonyl it is neutral, correct, 0 charge it is having, carbonyl. So, it is 0. So, 5 into 0. So, ion also it is 0, but you have to mention it as 0. Check for the next one. No cation is present on the left hand side. So, So, directly we will arrange the ligands in the alphabetical order and write the names. So, see the names of the ligands. This is amine, right? This is chlorido, right? So, amine and chlorido, A will come first. So, I will write this name. So, it is diamine because 2 are there, diamine, correct. How many chlorine are there? 2. So, it is dichloro. What is the name of the central metal atom? As it is, because no cation is present, platinum. Now, find the oxidation state of the central metal atom. So, it is diamine, it is 0, correct. So, diamine, that is 0, 2 chlorine. So, X value for platinum, diamine, that is 0 plus 2 into chlorine minus 1. So, X value, if you find, it is 2. Let us check the next example. Okay. How to name this coordination complex? That is, cation is not there. So, we will directly go for the ligands. How many ligands are there? First 2 aquo, right. Water is called as aqua or aquo. This is amine, right, A-M-M-I-N-E. So, aqua and amine, which will come in the alphabetical order first? Amine, right. So, we will write that first. So, it is diamine, diaqua or aquo, copper, right. Now, we will write the central metal atoms oxidation state, and last we will write chloride, which is the counter ion. So, find the central metal atom oxidation state. So, this is X value for copper, 2 into 0, water it is neutral, 2 into 0 because amine is neutral, plus 2 into minus 1 for chlorine. So, it is 2. We will go to the next example. Cation is not present. So, we will go to the ligands here. The ligand present is ethylene diamine, right. Ethylene diamine. Now, how many are there? 3. Now, in this ligand name already the word di is there, right, diamine, di is there. So, the word will be tris. So, it is tris ethylene diamine, tris ethylene diamine, cobalt, CO, that is the central metal atom cobalt. In the small bracket we will write in the Roman the oxidation state, and what is the counter ion here? Chloride, right. Now, find the oxidation state of cobalt, X plus En, it is neutral, right. So, it is 0 and 3 into minus 1, correct, 3 into minus 1. So, if you calculate this, you get it as 3. So, hope the nomenclature is clear to you. If any doubt, please write it in the comment box.